Hi, and welcome to another video from Thinking for Fun. In this session, we are going to look at the definition of a surd and work through examples on how to simplify, add, subtract, multiply, and divide surds. So let's begin by looking at the definition. A surd is a root that has an irrational value. These can be square roots, cube roots, or roots of higher order. For example, square root of 2 is a surd, as its decimal equivalent cannot be expressed as a fraction. Other examples of surds include square root of 88 and cube root of 91 as shown on screen. Some roots can be expressed as fractions and are therefore not surds. It's worth noting that the expression 6 root 2 is just a shorter way of writing 6 times root 2, in the same way as 6 times x is written as 6x. Surds can be added and subtracted in a similar way to adding and subtracting algebraic expressions. Consider 5x plus 3x equals 8x. If you think of this as 5 lots of apples plus 3 lots of apples equaling 8 lots of apples, then similarly 6 lots of root 2 plus 5 lots of root 2 equals 11 lots of root 2. Examples involving more than one variable can be solved, like the one shown on screen. Now let us have a look at multiplying and dividing surds. There are two rules to consider when trying to solve any problem involving either multiplication or division of surds. The first rule states that the root of a times b is equal to the root of a times the root of b. The second rule states that the root of a divided by b is equal to the root of a divided by the root of b. The two rules are displayed on screen in the normal way and in reverse. Using the above two rules and the normal rules of maths, it is possible to simplify, multiply, and divide surds. However, before trying to solve any commonly set problems involving surds, it is worth considering the squares and square roots of the numbers 1 to 10. These are shown at the right hand side of the screen as a reminder. Now let us have a look at some worked examples. Example 1 involves simplifying the square root of 75. Like this, firstly find the greatest square factor and then split the number into the factors. In this example, the greatest square factor is 25, so it can be rewritten as 25 times 3 as shown in step 1. Next, use rule 1 to break the surd into two distinct roots. So here we will end up with the square root of 25 multiplied by the square root of 3. Finally, simplify the roots as far as possible, giving us 5 multiplied by the square root of 3, which we can rewrite as 5 root 3. Example 2 involves multiplying two surds together. Here we have the square root of 6 times the square root of 3, which using rule 1 in reverse gives us a square root of 6 times 3, which equals the square root of 18. Example 3 demonstrates the division of two surds. By using rule 2 this time, we can rewrite the problem as the square root of 18 over 6. Then this fraction can be calculated, giving us a final answer of square root of 3. Before we start the next example, it's worth remembering that the order of multiplication does not matter. For example, a times b is the same as b times a. We can use this rule when multiplying surds. As shown on screen, if multiplying a root x and b root y, this can be rewritten as a times b times root x times root y. The next example shows multiplying two roots together and then simplifying the answer. In the first step, we rearrange the equation as the order of multiplication does not matter. Then in the next step, we can then multiply the whole numbers together and multiply the square roots separately. This gives us a value of 8, and using rule 1, a value of the square root of 3 times 12. Simplifying the values and carrying out other multiplications as necessary, we arrive at the answer of 48. For the next example, there are two things to bear in mind. Multiplying the top and bottom of a fraction by the same number is equivalent to multiplying the fraction by 1, and therefore it is unchanged. Also, multiplying the square root of any number by itself equals the number. This final example involves rationalising the denominator when it contains a surd. Here we have 5 divided by the square root of 3. In order to rationalise the denominator in this example, it is first necessary to multiply both the top and the bottom of the fraction by the square root of 3. The final answer is arrived at by using a combination of Rule 1 discussed earlier and the normal rules for multiplying fractions.